All right, we can see your screen.
Hi. Perfect. So, hello everyone. I'm Abhimanyu Sharo3, presenting on behalf of the Center of High Performance Systems and High Performance Engineering Laboratories in Ingram School of Engineering, Texas State University. And first of all, I'm like super honored and excited to present our research on digital twins for material handling operators in Industry 4.0. And I believe this is our take to contribute by research to this ever-growing and transforming field of Industry 4.0 and digital twins. So, beginning with the agenda of today's presentation, I'll be starting with a short background on the research, our methodology, what we have developed, some challenges, a short demonstration of our research, and the next steps. So just a quick overview on the digital twins. So as we saw in the presentations this morning and right now, we have created digitalized versions of multiple machinery and systems these days. And this, a digital twin can actually be defined as a digital version of any actual machine carrying capabilities to replicate an existing system in real time, which is simulating its physical state and the behavior. So nowadays, digital twins are working constantly to monitor machinery, warehouses, and production facilities to increase reliability of components, lower waste, and increase profits. So, and fun fact, these technological marvels are not only limited to manufacturing sector now. Singapore, one of the world's densely populated nations, has now created a digital twin of their entire nation, mapping their geographical and infrastructure data. And now this system is actually helping the government with the policy making, planning, operations, and risk management. And I believe we all can imagine the gains with that system in place. So with all the available technologies, it is us humans that are actually at the center of this evolution. And yes, we have robots and all these amazing facilities assisting us, but those super smart machines, we don't believe they hold the capabilities to replace us yet. So just some quick stats. So according to Data USA, as of May 2021, 1.08 million people were employed in warehousing and storage industry. And around, I would say 40% of the human workforce performed manual material handling jobs as a daily work. And the material handling is actually considered one of the most physically demanding tasks in the workplace. And it can quickly become a leading factor contributing to a worker's accumulation of mental and physical fatigue. So, and there's a research which has been going on since 1972. It has shown us that yes, the injuries and fatalities occurred by workers have decreased, but there's still a need of research to make workers safe on the job floor. So, and the musculoskeletal disorders caused via fatigue actually account for over a third of all the workplace injuries. And these injuries not only harm the workforce, but also cost employers around $13.4 billion every year. So we humans plan to incorporate these limited attempts have been made to connect the digital twin technology to human operators working in factory environments. So our research here at Texas State University tends to bridge that gap and provide a framework to build a true digital twin of an operator in today's Industry 4.0, or I would say Industry 5.0 environments. So it all started in 2015 when our research team worked on a Kaizen project with Toyota to develop a simulation process for human motions using 4 motion capture cameras, where it all started from. We got them from the Department of Health and Human Performance to understand the technology in our field. Next came in some funding from NEC as a gift to continue the research, adding 4 more cameras to our inventory. And then multiple internal and external grants later, our team now includes faculties from the School of Engineering, Business School, Health and Human Performance, and all collaborating towards the same goal, towards the same project. And our labs now house a fleet of 13 motion capture cameras for biomechanical studies, smart suits and watches for physiological body parameters, And we also have an electroencephalogram EEG device for the cognitive sciences as well that we are planning to incorporate in near future. So one of the main scopes of our work is that we have actually built a conceptual framework to construct a digital twin for a material handling operator. And in order to detect fatigue as a factor of change in various body parameters such as joint kinematics, heart rate, breathing rate, etc. So as we can see, the framework includes 4 modules of development. The data collection module, data pre-processing and storage. We have the analytics, and then the augmented module. So the initial development starts with the collecting data in a controlled lab-based environment, replicating the fundamental moves performed by a material handling operator in their daily work. And these moves include motions like lifting, lowering, picking, pushing, pulling of various weights in different scenarios. And collected data is then stored in a local database and analyzed for building either fatigue prediction or activity classification algorithms using mathematical models. Regression, we have used regressions in the past, dynamic time warping, and various other ML models in order to incorporate towards the end goal of the digital twin. And the analyzed data, its end use case, is then fed into environment in real time, analyzing the activity with additional statistics based on the requirements. So the major outcomes so far from this, I have it summarized in this slide here, where we have, first of all, we have a digital twin lab with motion capture facilities serving as a platform to constantly advance and evolve the research and field of material handling. And our concept of a virtual worker, the digital twin of a worker, holds the capabilities to collect, store, analyze, and display data in real time. And the advanced data-driven fatigue models that our team has developed through our time, and we can predict human fatigue as a factor of rate of perceived exertion of an operator as a function of their multiple physiological factors taken into consideration. And then since we are collecting data since 2015, we hold a large repository of human motion capture data performing fundamental skill moves. And on the top, we also have the visualizations and graphics of the worker in real time, which can be projected using Microsoft HoloLens. We have built the immersive environments in Unity. And this AR pipeline actually enables generating avatars of a person in a Unity environment using the motion capture data in real time. So the image on the screen is actually a screenshot from our Unity environment with real-time stats. I have a video performing with this activity in a couple of next slides. So the image on the screen, again, screenshot from Unity. It has stats of the activity, such as the time of the activity. It counts the number of lifts, lowering, assesses the motions, whether it was a correct lift, an incorrect lift, and also the real-time feed, which is showed on the right-hand corner, that is integrated into the system as well. And the dashboard also holds the capabilities to show real-time heart rate of the individual, which is collected and integrated with the Higgs-Susskind smart suit that we have in our lab. So the operator fatigue in this example is actually a measure of a factor of Borg's rate of perceived exertion, which actually ranges from 6 to 20, 6 being no exertion at all, to 20 being very, very hard exertion by the individual. So, and some other examples of the real-time ergonomic assessments are displaying of joints of concern for each individual in the 3D environment using audiovisual cues. Like we can see the red beacon on the knees of the avatar in the example on this particular slide. And the system also records the task statistics for future and for further analysis. So it holds the capabilities to do that in real time as well. So now I have a demo for all the attendees showcasing the digital twin with real-time feedback system. So please let me know if you're able to hear the audio like after 1 or 2 seconds.
We can hear the audio.
Thanks.
A digital twin is an avatar copy of a material handling worker, mirroring human motion as the worker performs a task. Wearables mounted in the worker monitor physiological activity. This system enables real-time health and ergonomic assessment and optimization. The avatar is created by optical motion capture cameras, which read reflective markers mounted in the workers. A hexoskin suit tracks the worker's ECG, heart rate, and oxygen consumption. Our team replicated manual material handling activities to test the digital twin. Audio and visual cues are triggered when a wrong motion is detected. Such feedback attempts to reduce workers' injuries during repetitive moves. The dashboard displays real-time indicators, such as workers' fatigue, heart rate, and task statistics. Data-driven models predict the rate of perceived exertion, an estimate of fatigue measured in the Borg scale. An augmented reality application was created using Unity and Qualysys SDK. Avatar's advanced graphics and visualizations, generated in Microsoft HoloLens, submerge the user in a more realistic environment. Digital twin technology brings material handling workers closer to Industry 4.0, increasing their safety, facilitating their training, and connecting them to smart devices.
So our current development is towards adding more physiological parameters to the data collection and also closing the gap between the lab-based data to a factory floor. So right now, all the data collection that our team has done, it's lab-based. So we are trying to find on and work on alternatives for super precise optical motion capture cameras that we have and using low-cost off-the-shelf video cameras. And we are right now experimenting with the post-estimation algorithms on video recorded data that actually allows us to detect the human joints and extract the joint coordinates, which can then be integrated to our already previously built digital twin framework by developing models to actually detect the material handling fundamental moves and also create the augmented reality models in real time. And these models can also be used to automate the ergonomic assessments that are widely used in the industry currently. So I have another video without audio this time. So this video is actually an example of our current development of the joint assessment algorithm that's working in real time. And the subject here is performing basic lifting, lowering moves. And the system is able to actually detect the joints, and in future we would like the model to actually detect the activity that is performed by the individual, like we have those cues on the screen, which are just for demonstration purposes right now. So as the person does these jobs, the model should be able to detect what kind of motion is happening in real time. So, so I think towards the end, I would say that this digital twin framework that we have developed at the Texas State University can further be enhanced to build such digital twins for humans, like what we have on the factory floor for astronauts as well. And they can be used in use for training, zero gravity material handling, and the real-time health monitoring and ergonomic assessments like we have Pro in our lab. We believe it can be taken to the next level that closely aligns with NASA's technology readiness levels as well. And towards the end, I would like to just summarize our project's impact so far from where we were. And right now, during the course of which we are now a team of 9 multidisciplinary faculty members who have assisted publishing more than 5 masterpieces, multiple journal articles, conference papers, and poster presentations, along with a team of graduate and undergraduate students participating in our research. And that's all I had. Thank you. This is our contact info.
Awesome. Well, thank you for the presentation. I see that we have one question in the chat session. Dylan, do you want to go ahead and ask it?
Mm-hmm. So it's an SDK that we have that integrates our motion capture system and Unity, and we use Qualis's motion capture systems. So the SDK is a bridge between Qualis's and Unity. Yeah, you're welcome.
I have one question on your post-estimation work. Do you use a stereo camera?
We'll be using a GoPro to take the videos. Yeah.
All right. Thank you. Any other questions from anyone around the loop?
Just a comment that this is really good work. As a flight surgeon and occupational medicine physician, 30% of disease and disability and death actually is on the job. And so by properly evaluating how to prevent all that is really a win for not only the worker, but also their family and their career. And also it helps, of course, long-term for the corporation. And then it really helps people to really meet their performance. You can design the equipment and design the job to help the human themselves. So really hats off to you guys. Over.
Thank you so much.
Definitely great work. Any final questions from anyone? All right, I'll take silence to mean no. Again, thank you for the presentation. Next,